Hello everyone, this is Ayush and welcome to this video on demystifying async await in C Sharp. In this video, we'll discuss what async await is, why it's useful, and how to use it effectively in your C Sharp code. We'll also cover some best practices and tips for working with async await, as this being the motto of the complete series. So, first let's define what async await means in the context of C Sharp programming. Async await is a programming pattern that enables asynchronous programming in C Sharp. Basically, async is a keyword that is used to declare an asynchronous method, and an asynchronous method is a method that can execute independently without blocking the main thread and perform some long running operations in the background. And when you are using an async method, it can use await keyword to await the completion of an asynchronous operation. This frees up the calling thread to continue execution until the awaited operation completes, at which point async method resumes execution from where it left off. That's about theory. Let's take a code example and understand what async await does. Okay, so for this demo, I've created a console application. From the code perspective, this is just calling an API synchronously and doing some console logs. So if you can see, like the main method is started, it's logging the thread on which main has started. Then it is calling the sync method on which before the API call is made, on which thread it is running. Then we made a API call. Then after the API call completed, on which thread it is running. Then I've added a delay of 1 second, and finally on which thread again the call has completed. After that, there are some console logs that I've added and which are independent of the call sync method which is happening. And then at the end, when the main ended, on which thread it ended. So if I run this, you'll see the main thread started on thread 1. Synchronous call also happened on thread 1 before and after. And after that call sync completed again on thread 1, there were some console logs, and then main end also happened on thread 1. So here, if you see, I'm just running everything synchronously. I'm not utilizing the power of asynchronous programming. I'm not utilizing the power of multi-threading. And on the side note, if you want to understand what exactly multi-threading is, I have created a short. Go check it out. So this is not at all like it's all synchronous in nature, right? So I'm not utilizing the resources that are available to me. So how to write a asynchronous method corresponding to the same call sync method, right? So if I go and copy paste this here, I'm going to just make it call async 2 because I've already created one. So call async. This is also async. Just to add the logs properly, let me just type that out. And here, rather than using this, I'll make it async. First of all, I need to make my method as async. After that, as it is a async method, I need to await that. As this is a await is getting used here, I need to make this as a async method, right? So I made this as an async method. Now my call async to method is ready. But but how do I call this from the main method, right? So in main method, if I go and if I just type call async to, right, and I await this, again this is a void method, it will not work. So I need to make it as task, and I need to make this method also as async. So once I have this, you see that everything works out, like there is no problem, there are no console logs which are happening. Let me run this, right? So if I run this again, this time if you see, the main started on thread 1. Before the API call, it was on thread 1. After the API call, it is on thread 7. And when the async method completed, it is on thread 7. And still the logs are coming afterwards. And the main thread also ended on, main also ended on thread 7, right? But one thing is, basically we are able to utilize the concept of multi-threading. But are we doing everything right? No. See, there is some piece of code which is not at all dependent on what is the response that I'm getting from the call async method, right? So what I can do here is I can just create a task T1 for this call async to method. and then before I need to say that, and I can execute other things which are there, and before I need to have this data, that whatever I am getting from call async to, I just need to await it. So let's say if there is a code which is dependent code on T1 task, I should have this. Before that, I should await this, right? So now if I run this, you'll see that main thread was started on thread 1, async method happened. This time the logs which were there has already been published, and then the async call completed, and the call to main also ended on thread 7. So everything, you are able to not hold off onto the main thread, right, till the time it is not required. So that's basically from async and await perspective. If you see again from the theory perspective, right, async made this particular method as an asynchronous method, and await is where I want to await a specific asynchronous task which has happened. Okay, so if you want to understand more on how C Sharp handles async await internally, try ILSpy. I'll show you just a quick demo of like how ILSpy works. So I have already installed that extension of ILSpy. In here you will see this. Okay, the async await method is there. Inside this there is a program file which is there, and then inside this the call async method that I'm doing, right, call async d2 method that I'm doing. This is also having a move next. This is the IL code that you can go through and understand how async await is internally handled. Just to give you a glimpse, it's using the state management. And if you want me to give an more in-depth detail around this ILSpy and how to read through this code, do let me know in comments. We will make a separate video on that. Okay, finally on the best practices related to async and await. While async and await can be a powerful tool for improving the performance and responsiveness of your C Sharp application, it's important to use it correctly in order to avoid potential issues. One best practice is to use cancellation tokens to cancel long running tasks if they are no longer needed. This can help prevent your application from becoming unresponsive or hanging if a long running task takes too long to complete. To give you a demo on this, let me take you back to the code. Okay, to show basically how cancellation token can be used to cancel the long running task and how it should be implemented in C Sharp, I've created a sample .NET Core Web API application. And in that, every controller action that I'm having, right, I have embedded the cancellation token here as a parameter. And in this, I'm just creating a HTTP client, and first I'm delaying for 3 seconds, and then adding a console log saying that it waited for 3 seconds, and then making a API call again to bing.com, fetching it. The only thing which I'm doing different here is adding the cancellation token as part of the second argument. Okay, so now on Postman, if you see, I'm running it on localhost, and let me just make a send call first to see that get call was started. It waited for 3 seconds, and then it made some HTTP calls, and finally get call was completed. Right now, in this case, let's say if I make a send call and I click on cancel, this time you will see that I did a get call started, but the task was cancelled, and finally get call was completed. So it didn't go and call, waited for 3 seconds, and it didn't go and made a API call to this HTTP client implementation, right? So that's how you can basically use the cancellation token to cancel a task which is not itself required now, or to cancel a task which is running for a long time. Another best practice is to avoid using async void methods, as they can introduce potential issues with error handling and exception propagation. Instead, you should always use async task or async value methods. It's also important to avoid blocking on async methods using the dot result or dot wait methods, as this can introduce potential deadlocks or performance issues. Finally, you should avoid using async await for short running or CPU bound tasks, as the overhead of a synchronous programming pattern can actually decrease the performance in these cases. To conclude, by identifying the long running task in your code and using the async await pattern to asynchronously wait for the completion, you can improve the performance and responsiveness of your application. Thanks for watching. See you in next video.